All right, today you guys are going to learn how to graph linear equations, okay, with two variables, all right, using a table of values. And so you guys should be on the front side of your worksheet. Okay, the front side is the one with the three problems. All right, so we're going to go through step by step how to do this, and you guys will see for some of these equations we're just going to go ahead and insert any value for x. We're going to use x as what we call our input. So we're going to plug in for x to find y, right? So when we plug in for x, we're using an x value, we're using a number for x, okay, which will be our x value. And then our output, our answer that we get, will be the y value. So we'll have an ordered pair, okay? So for instance, we'll plug in 2. If we get an answer of 4, then 2, 4 is the point we will plot, okay? And what we want to do is we want to be able to find ordered pairs, x and y values. They're whole, okay, and no parts. We can use them with parts. It's just the ones with fractions are harder to plot accurately on a coordinate plane. So what we want to do, and you'll see in a couple of examples, we want to be able to choose x values that will give us a whole number for y, even if it's negative, okay? So here we go. So the first equation that we have is x plus y equals negative 3. All right, so locate that. This is number 1. All right, and so what we're going to do is we're going to create an x and y table, and you're going to do this just to the right of the graph. Okay, so we're going to go ahead and draw, and we'll be using a table such as this. Okay, and you guys will see the y side is going to be a little bit larger space because we're going to put the equation here where we plug in. So we're just going to pick some numbers, okay, and you'll see that they'll change as we go through. For the reason I said earlier, we want to get nice answers, things that we can plot easily. So we're going to first off, let's just input 2, all right? We're going to input 2. And so that means we're going to plug in 2. You can see it's our x value. So I'm going to replace x with 2 plus y equals negative 3, all right? And you guys are going to show this work in every single problem that you do today, all right? Every single graph. And you guys will have 6 that you'll be doing on your own, up to 6. All right, and so we go ahead and do the math here. And so what we're going to do to get y by itself, right, we're going to move this 2 over with the negative 3. And how do we move it? We subtract 2 from both sides, okay? And so when we subtract 2 from both sides, right, we're going to subtract that 2, right? So you get this negative 3 minus 2, which is negative 5. Which means when I plug in 2 for x, right, when I plug in 2 for x, okay, I get a value of negative 5 for y. Okay, so everybody go plot that. That's 2 to the right and 5 down. That should fit on your coordinate plane. And that's what we want to do too. We want to make sure these ordered pairs fit. Okay, so we don't have to manipulate the graph. All right, so the next one we're going to plug in is we're going to plug in 1. Okay, and so we're going to insert 1 for x. And you can see it's the same pattern each time. Okay, we're plugging 1 in this equation. So to find the value of y when x is 1, all right, when x is 1, what is y? I'm going to go ahead and isolate y. I'm going to get y by itself. That means I'm going to move this 1 over with the negative 3. Those are like terms. I'm going to subtract the 1, right? And so negative 3 minus 1 is negative 4. Okay, go ahead and plot that, please. That's 1 to the right and 4 down. Okay. Then we're going to go ahead and insert 0. This one is going to be easy because we're not going to have to move anything, right? 0 plus y is just y. So y is already by itself. When we add 0 to y, we get y by itself. I do not need to move the 0. You do not want to embarrass yourself by subtracting 0 from both sides. We know that doesn't change anything. 0 plus y is just y. And so we get y is negative 3. Okay, so if you guys go ahead and plot that, please. And then we're going to plug in negative 1. But this time, look what's going to happen. We're going to plug in negative 1, right? Which means to isolate y, I'm going to need to add that 1. And so negative 3 plus 1 is negative 2. All right? And the last one we're going to plug in is negative 2. And once again, so here's the thing that I'm going to try to convince of you. Sometimes inserting a negative value for x actually makes the math easier, okay, instead of just positive numbers. Because the negative number, when we insert it, to actually isolate y, we're going to add it, which makes it positive now. So we're going to add that 2. And so we get, when x is negative 2, when we insert negative 2 for x, we actually get negative 1 for y. So we have 5 points here, and you guys will see when you plot these 5 points, they make a straight line, okay? And why are these linear equations? Let's review this really quick. X is to a value, a power of 1, right? And it's not dividing by x. So as long as x is to a power of 1, we're not dividing by x, that is going to be linear. All right, let's look at example 2. And this is where it gets a little tricky, okay? You can see no matter what we plugged in that last equation, we were getting whole numbers, okay? Even in some cases negative. So here's our equation. This is number 2. Let's go ahead and build our table. Okay, we're only going to plot a couple points on this one because you guys will see we're not going to have as many nice answers to choose from. All right. All right, so the first thing I'm going to do, and I'm going to do what I did on the last one. I'm going to plug in 2. Let's just plug in 2, and I'm going to show you why we probably necessarily wouldn't plug in 2. All right, so that's 2 for x, right? It's being multiplied by 3. So we're here. Okay. So we're substituting 2 for x. We're inputting 2 for x, okay, this linear equation, which is to a power of 1, right? Okay. We should get a straight line. We want to make sure we get that. All right, so what's 3 times 2? It's 6. Okay. And now to isolate y, we're going to subtract that 6 over, right? But here's the thing. You see we still have this negative y. Negative 4 minus 6 is negative 10, okay? Now we need to get rid of this negative off the y. That means the opposite, right? The opposite of what is negative 10? Well, the opposite of 10 is negative 10. But if we don't see that, we can always insert a 1, right? There's an understood 1 here. And we can divide both sides by negative 1. And what we end up with is, right, we end up with 10. Now this is a nice ordered pair, right? But when we look at our graph, do you guys see 10? We go 2 to the right and 10 up, but we don't have 10 up, okay? So even though this is a nice ordered pair, so we want to pick values that are going to fit on our graph, all right? So let's try something a little bit smaller this time. And I would always recommend plugging in 0, okay? So 3 times x, 3 times 0, minus y equals negative 4, okay? So we're substituting 0 for x. 3 times 0 is 0. What's 0 minus y? Well, that's just negative y. And if you remember, what did we insert here? What's the same as taking the opposite of y? Multiplying by negative 1. So we divide both sides by negative 1, and a negative divided by a negative is positive, and so y is 4. So if x is 0, y is 4. And this one fits, so that means 0 to the right or left, we go up 4. So from the origin, go up 4, and mark that. All right, we're going to do one more point. 2 points make a line. Let's plug in negative 1. Okay. So this is 3 times x minus y equals negative 4. X is negative 1. Let's go ahead and put that in already so we don't forget about it. What's 3 times negative 1? Negative 3. And like the first example, if you remember, to get y by itself, we're going to add 3, right? It's negative, so actually this is a good thing, so we're going to add 3. So that's, remember, don't forget about that negative on the y. Negative 4 plus 3 is negative 1. What's the same thing as taking the opposite of y? Multiplying by negative 1, so we're going to divide both sides by negative 1. And what we get is, what's negative 1 divided by negative 1? It's 1. All right. So let's go ahead and plot that. That's 1 to the left, and then up 1 and plot it. Now connect those 2 points, and there's our line. Okay? These are all linear equations. They're all x to a power of 1. All right, last example. 2x plus 5y equals 15. All right. Okay, so we need to be careful what we plug in here. We want it. Remember the last, and you'll see this. We're gonna insert 5 first. What I want you guys to notice, we're plugging in for x. Okay, is that I'm going to multiply by 2, right? Whatever I insert for x, I'm going to multiply by 2. I'm going to double. Okay. Then I'm going to move that with the 15, right? I'm going to move that 10 over with the 15, and my very last step every single time is going to be dividing by 5. Because this 5y will never change. I'm plugging in for x. This is what I'm going to end up moving and then dividing by the 5. So what I want to make sure is, when I move this 10 over with the 15, is that going to be a number that's divisible by 5? Will it divide evenly? So you're going to have to try a number of different numbers, okay, that will give you a number, all right, over here, that will be divisible by 5. All right, so I'm going to subtract the 10, because 10 minus 10. And you guys see that 15 minus 10 is 5. That's 5 is a number that will be divisible by 5. And we divide both sides by 5. Y equals 1, right? And so this is, we can easily plot that. So that's 5 to the right and 1 up. Now I'm curious, if 5 works, why don't we try negative 5? Let's see if that works also. So once again, we're doubling x, right, plus 5y equals 15. So I put the now remember, you notice every single time I'm writing out the x value first, and I'm just trying to find y, my output. 2 times negative 5 is negative 10, okay? And much like the other 2 examples, when we plug in a negative, we get a negative here, which actually makes our math easier, because then we're going to add that over. Now, when I add 10 over, is 15 plus 10 a number that's divisible by 5? Think about it. If I add the 10 over here, is 15 plus 10 a number that's divisible by 5? And the answer is yes. Okay. So we get 25, and when we divide by 5, y equals 5, right? So when x is negative 5, y is 5. All right, our last value that we're going to plug in, and I would always recommend trying this number because it's the easiest one to work with, is 0. Okay, get in the habit of plugging in 0. It doesn't always give us something nice, but at least the math is simple, because when you plug it in, it makes that expression go away. Do you see? Wherever we plug it in, 2 times 0 is going to be 0. This just goes away. All right, so let's put this over here. So 2 times 0 is 0. 0 plus 5y is 5y. Now, is 15 a number that's divisible by 5? Yes, it is. And so how many times is 5 divided into 15? And the answer is 3. So if you notice here, we have 3 ordered pairs, okay, that are something that we can graph. All right? And so this is what you're going to do. You're going to create tables. You're going to insert numbers for x, try a variety of numbers. If you get a fraction, use it. But what you want to do is you want to at least have 1 or 2 points that contain no fractions. So you know that you're accurately plotting those 2 points. All right? If you need to converse with your partner to kind of strategize, that's fine. But this is an individual activity, and you're going to get as many of these 6 problems as you can done on this minimum day. All right? This is going to be turned in. Okay? I'm going to be looking it over. I want to see that you've been working. Okay? And the only way that I can see that you're working is by you putting your pencil to the paper and not staring at it. Okay, so the expectation is that you're getting a lot of these done. I don't know how many a lot is. A lot might be 3, it might be 4, it might be 5. I know your ability level, so I know what you're capable, I know what your a lot is. Okay, but the expectation is you're working this entire time. All right, guys, have a great rest of your day, and I hope these notes will help you. All right, guys. See you tomorrow.